This video will describe the input data of the Demo 1 model. To get to this point, please see the How to install Backbone and run demo model video. I have opened the input data Demo 1 Excel here, so let's study the input data. First of all, comprehensive instructions are provided on the instructions and maps sheets. On index sheet, there is a list of all the sets and parameters that are translated to Backbone in GUMS in order to define the grids, nodes, and units of our system. The sheets in white and gray are the input data sheets, so you define the objects and fill the parameters there. Most important ones are the node data, where you define grids and nodes, and unit data, where you define units. In node data, you will notice that one row equals one node. Nodes are the unique inputs here, and the grid they are associated with is specified next to it. The first parameter of our node is the selection of node balance. Node balance true means the energy balance for this node is on. It is used for nodes that have to have the same amount of demand and generation or input and output. Use price true, on the other hand, means that the commodity comes from outside the model and its price is defined. Next, we defined storages. In Backbone, only nodes can store energy, not units. To activate storage, energy stored per unit of state is flagged as 1. From now on, we will not go through individual parameters, but to understand what they are used for, there are two places. First, on the instruction sheet, there is a description of each node and each unit. Second, under Backbone, Inc folder, there is a file called 1A definitions. You can find descriptions of each parameter there. Next, on node data, we can define emissions for the node, groups that the node belongs to, and transfers between other nodes of the same grid. Let's move on to unit data and consider the first unit. It's linking biomass node and district heating node, like described here in maps. You will first notice that the same unit is defined twice for biomass input and for district heat output. Not going through all the possible parameters, but listing the mandatory ones. You will have to give your unit capacity, a conversion coefficient, a unit type, an efficiency calculation setting between off, linear, or MEP for all time levels, availability, and efficiencies and operating points corresponding to the efficiency calculation selection that you have made. Additionally, you can assign a multitude of parameters like operational costs, possible operational constraints, groups, reserve properties, maintenance breaks, and calculation aggregation. Notice that different types of units, like flow units or units with multiple outputs, may have different mandatory parameters associated with them. Finally, some units can be invested into and some can't. To allow investments, you fill out the unit investment parameters. These include unit size, investment cost, unit count, and become available at time step 1. Additionally, maximum and minimum investments and other constraints can be set. To add a new node or a new unit, simply input the name of your node or unit on any row below, assign its connections to grids and nodes, and give it parameters. The checks in the gray columns will help you spot errors in inputs. The other necessary sheets to define these sets and parameters to GUMs, like shown in index, are automatically updated. Further, to understand the output of the demo model, please tune in for the next video.